Hi everyone, I'm Paul Drobny and I'm a data scientist and AI resident at AppZiva. At AppZiva, I get the opportunity to work on challenging real-world AI and machine learning projects in various industries. A common product banks offer their customers is a term deposit, such as a certificate of deposit or CD. This is a cash investment where the investor agrees to deposit money at the bank for a specific period at a guaranteed interest rate. This in turn gives the bank a source of funding for their financial operations. Call centers are often used for marketing campaigns to reach out to potential customers, generate interest in the product, and if successful, guide them through the purchase process. In this video, I'll discuss how I improve call center efficiency by using AI to determine high potential clients and customer segments. The client for this product is a small enterprise startup primarily dedicated to providing machine learning solutions in the European banking market. The team is interested in developing a machine learning system that utilizes information gathered from the call center with the goal of enhancing the success rate of any product offered by their own clients, which in this case is a term deposit subscription. We were given 3 goals by the client: predict if a customer will subscribe to a term deposit, identify likely customers and determine the customer segments they should prioritize, and determine which marketing features make the customer buy. The data provided by the call center includes the target attribute Y, which is whether or not the customer has subscribed. They also provided customer info, which includes the age of the customer, type of job they have, their marital status, education, whether or not they have default in their credit history, their average yearly balance in euros, whether or not they have a home loan or housing loan, and whether or not they have a personal loan. They also included marketing campaign info, which includes the contact type, the last day of contact of the month, the last contact month of the year, the last contact duration in seconds, and campaigns, which is the number of contacts performed during a campaign for this client. The data was made available in CSV format. Once downloaded, the file was read and copied into a data frame. The head function was used to look at the first 5 rows for a quick check to confirm that the data is in the expected format. Now that we have our data available, we can move forward with exploratory data analysis. To start, we check the data for completeness. With the isNull function, we confirm there are 0 null values or missing data in any of the columns. Using the dtypes function, we check the data types for each column. With everything checking out, there is no data cleaning needed at this point, so we can continue with further analysis. The describe function generates a brief statistical summary of the data, including count, mean, min, max, and with the quartiles, we can get a good idea of the distributions, but only for the numerical features. Since the dataset contains categorical data as well, we will need to rerun the describe function, this time adding include object. For the categorical columns, we get the count, but now we also get the number of unique values for each category, the most frequent value or category, and the frequency. To get further insights, we can split the data between subscribed and not subscribed and rerun the describe function. For this project, SQL was used to create 2 new data frames by filtering the data for a target variable Y, for yes for one data frame and no for the other. Now we can see a statistical summary for the numerical features for subscribers and non-subscribers and compare the results. Both groups have similar values for age, day, and campaign. Subscribers have a slightly higher balance, and duration is 3 times higher compared to non-subscribers. Repeating this for the categorical features, it can be seen that we get similar results for subscribers and non-subscribers, with the exception of job type. For the subscribers, the most frequent job type is management, and for non-subscribers, the most frequent job type is blue collar. Next, we'll use various plots to look for any patterns in the data. Since we have 14 features, I use Tableau to create and organize the visuals. With the pie chart, we can see the term deposit subscription rate is 7.24%, with only 2,896 subscribers out of the total 40,000 customers. With the imbalanced data set, it's difficult to see if there's any individual features contributing to a higher or lower subscription rate. What we can see is there are no subscribers that have a default in their credit history or unknown education level. However, there's only a small sample size in these categories. For the marketing campaign info, duration of the last call is higher among subscribers. This is likely due to subscribers spending more time on a call getting processed into the term deposit and not longer calls leading to getting more subscribers. For the other factors, there's no obvious relationship to the subscription rate. The primary goal is to identify which customers are more likely to subscribe, so we'll be utilizing the customer info to develop the predictive model. With a mix of numerical and categorical data, we will need some data preparation. With a subscription of around 7%, the data is overwhelmingly lopsided towards non-subscribers. To address this, we will evaluate 3 common rebalancing methods. One is an undersampling technique called random undersampler, which will reduce the majority samples to match the quantity of minority samples. The second is SMOTE-ENN. SMOTE stands for Synthetic Minority Oversampling Technique. This generates synthetic minority samples with some undersampling of the majority data. The third is SMOTE-TOMIC, which uses the same oversampling technique as SMOTE-ENN, but uses a different undersampling technique. For each of these methods, pie-chart will be used to identify the best performing model. A selected model will be evaluated against the original imbalanced test set, and the best model and rebalancing technique will be selected based on the highest subscribed F1 score. F1 score was chosen to find a balance between precision and recall scores. After the final model is selected and optimized, customer segmentation will be performed using k-means clustering. To prepare the categorical data, one-hot encoding was used to convert each category to binary values. Standard scalar was used to normalize the continuous data columns. All columns were then converted to type float. Before rebalancing, the data was split into train and test sets to preserve the test set in its original imbalanced state for later evaluation of the model. The data was split with 20% set for testing and the remaining 80% for training. Data rebalancing was performed on the train split using the 3 methods mentioned earlier. RUS decreased the non-subscriber samples to match the subscriber samples. Both SMOTE-ENN and SMOTE-TOMIC generated synthetic subscriber data, but varied in their undersampling of non-subscribers to balance the data. As we can see, now all 3 methods have approximately a 50-50 split between subscribers and non-subscribers. Pie-chart was initialized for each rebalancing method. The best model was then evaluated on the original imbalance test set. With the help of pie-chart, we identified the extra trees classifier trained on the SMOTE-ENN rebalanced dataset had the highest subscribed F1 score of 0.1655. So moving forward, this will be the model we'll use for a final training. Next, we'll optimize our selected model using Optuna to tune the hyperparameters. For evaluation criteria, we'll again use the F1 score of subscribers. After optimization, the final model was evaluated with the confusion matrix. Subscriber recall improved to 54% while maintaining a precision of 11%. The model effectively captured 54% of subscribers by contacting 66% fewer customers. Although the precision rate of 11% appears low, it marks a 57% improvement compared to the current subscription rate of 7%. To put this in perspective, if the call center continued to reach out to 40,000 customers, it would increase the number of subscribers by 1,655. Alternatively, they could get the same number of current subscribers they have, 2,896, by reaching out to 14,548 less customers. K-means was used to identify clusters or groups within the subset of predicted subscribers. To use K-means effectively, we must first determine the optimal number of clusters. One way to do that is the elbow method. The elbow method plots the inertia or within cluster sum of squares for a given cluster value. Inertia is the sum of distances of each data point to its cluster centroid, with the goal being to minimize inertia. As the number of clusters increase, the inertia also decreases, but at some point the rate of inertia decrease flattens. This point is called the elbow and is the optimal cluster count, k, for k-means. In this case, the optimal k value is 4. Next, we'll fit the k-means model with the optimal number of clusters of 4. The data is then grouped by cluster and summarized by the mean for each feature. 4 customer segments were identified. With cluster 2 containing only one customer, it will be ignored for this analysis. Common between the 3 remaining segments are: a majority have education secondary or above, they don't have personal loans or credit in default, on average have a positive balance, and it takes approximately 3 calls to turn the customers into subscribers. Looking at the differences between the 3 segments, we can break them down into the following categories: young and unmarried, with an average age of 32 years, 72% are single, with a higher rate of having a home loan, with an average balance of €900. Second group is older and married. With an average age of 51 years, 64% are married. They have a lower rate of having a home loan, with an average balance of €1,200. The final group is middle-aged and college-educated. They have an average age of 40 years, approximately 50% are in management jobs, 67% are college-educated, with an average balance of €12,000. 2 techniques were used to visualize the clusters: TSNE and UMAP. Both techniques can be useful to look for potential clusters, but they don't provide details on which features make up those clusters. With both techniques, there's quite a bit of overlap between clusters 0 and 1, and cluster 3 appears to be quite distinct in location in both TSNE and UMAP. For this project, a predictive model was developed, improving the customer subscription rate from 7% to 11%, a 57% increase. The rate of campaigns or calls needed per subscriber improved from 40 to 26, a 35% reduction. We were also able to provide our client with more information about the likely subscribers. 3 distinct groups were identified as young and unmarried, older and married, and finally middle-aged and college-educated. Common between the groups was a high rate of education level, secondary above, positive balances, no credit default or personal loans, and on average 3 calls were needed to close the sale. For more on this project, you can check out my article on Medium or the project repository on GitHub. Feel free to connect with me on LinkedIn by clicking on the links in the description below. Thank you for watching this video.